Hello, welcome back to the channel, PISTRIS Tutorial. It's Diana Baloy. You can call me PISTRIS. So today I have a video for you. I will be starting a series on physics for actually for all standards. You can use this at high school level. You can use this at at a tertiary level. So let's start with mechanics, right? So we're starting with motions and 1D. So this will be some sort of like a rundown on what is important under mechanics, right? Under motion, I'll just give you definitions. I'll give you types of motions, right? What is a motion? How do you describe it? The mathematical equations that we use to describe this. How to solve basic equations or even complex equations. How to draw motion diagrams like the velocity time diagram, the displacement time diagram, the acceleration time diagrams, right? So when we talk about motion, we're actually talking about what? About movement. So let me just draw a basic car here. So I'll just draw the Tesla Cybertruck, right? It's easy to draw. So if you don't know how to draw a car, you can just draw this one. It's very simple. uh okay, let's just draw it like that. So we have this, right? That, let's put that, and then let's draw a road for it, right? So we can just indicate this to show that it's moving in what? In this direction, right? So let's say, for example, our Tesla is set point x1 here, and then after some time it's at point x2 here, and then after some time it's at point x3, right? So that we don't have to draw a Tesla a model actually of a car which represent an actual car, because you can see, oh yeah, that is a car, right? We can just start using what? We can just start using something like a ball. So this will just show our what is this? Our objects, right? So this is a car, an actual car, and this we just use it to show an object, which could be a car, a ball, anything, right? This makes things easier to actually understand. So we have our car, so it was at this position, now it's at this position, now it's at this position, right? So let's indicate that with our with this object. So we can also do something like this. We'll indicate it here. This is its position, another position here, another position here, right? So let's say this is our road, but let's put this in a what? In a Cartesian plane now. That will be our x values, right? Our y axis, and this will be our x axis, right? So this is this. So this is x1, x2, x3. Okay, so that's our car moving to the right. So that's what we call motion, right? So that is motion on a plane or motion on a surface, right? So that's the movement. So when we talk about motion, okay, sometimes okay, let's say we want to understand what was the distance from x1 to x2. So we can just say that's change in x, right? We also want to understand, okay, what was the speed of the car? Okay, what speed was it using? So we'll indicate that with what? Vx, right? And okay, if we know the speed, can we find the acceleration of the car? Okay, so that is ax. So what does each of these mean? So let's just indicate that that's your acceleration, speed, and then this is your displacement. We'll call this displacement, right? The change in position. And this here, this is our position. It's a point in space, right? So it's a point in space. These are points in space. But when we take a change between these 2 points in space, we get a displacement, which is a distance, right? Why don't we just simply call it a distance? We'll get to that, but that has to do with the fact that we're using vectors, right? So vectors have a scalar quantity and a direction, right? So it's a displacement because it's in a certain direction, in the forward direction or in the x-axis direction. That's why we use change in x, right? So let's define what each of these mean. So displacement. Uh, so this is your change in position, right? Change in position. So displacement, mathematically you can write this as what? X final minus x initial, or x2 minus x1, right? So that's your displacement. So let's look at velocity, right? Because that comes after displacement. So velocity, it is the rate of change. Once we hear something about rate, you already know it has to do with time, right? It's the rate of change of displacement. Okay, rate of change of displacement. So let's just go back here, right? So we've said that we want to know how much distance did the car travel, right, from x1 to x2. What is the actual distance, right? That's displacement. We want to know the speed and the acceleration. But what about the time it takes to travel from x1 to x2, right? So we can also look at the change in time, right? So that's our change in time. Change in time is a very important quantity. Change in time, we use it a lot in mechanics, right? So that's the change in time. We're four um, quantities that we look at, right? So that pretty much sums up what motion is like. But yeah, so far it sums up what motion is like, right? So let's continue with velocity, which is the rate of change of displacement. So how do you write that mathematically? You write that like this: change in displacement over change in time, right? Which you can also write like the x over the t is the same thing. This one just represents when you look at it from when you're looking at very small changes, right? And then these ones are average changes, um, average, and these are instantaneous changes, right? So, but for this level, we'll be focusing only on the average change, right? So we can go ahead and remove this, and then we'll leave it like this, right? So that's your velocity. It's change in x over change in time. That's what the rate means. So let's look at what acceleration. Okay, so acceleration. This is the rate of change of velocity, right? So we represent this mathematically as ax is equal to change in vx over change in time, right? Which you can also represent as dv over dt, right? So this is our average acceleration. So I found displacement, velocity, and acceleration, right? So that's what we mean when we say we're talking about displacement. It's the changing position, right, of your object, and then the change velocity is the change in one, and displacement over the change in time, which is the rate of change of displacement. At what rate are you changing displacement, right? And then we also have acceleration, which is the rate of change of what? Of velocity. So let's just move. So now, so far we have looked at motion in a plane, on a plane, right? Where you have motion on a straight line, right? So sometimes you may find something like this. Let's say, for example, they represented motion. You have this object that closely packed around here. This shows the change, right? It's the same object that is moving, and then it shows something like this. it shows something like this, it shows something like this, and then it goes back to what, to this, and then it stops, right? This means something. Let's just indicate that Cartesian plane. All right, and then we have this x, right? So this means something when you have them closely packed here, and then they start spacing out but at the same distance, right? So this is what these are positions, these ones, x1, x2, x3, like that, and then the change in between its displacement, right? But we also say that the change in displacement over the change in time gives us velocity. When they are closely packed like this, it means that the velocity is very high, right? So the change is very high, right? And then when they space out like this, it means that the velocity here is higher than the velocity between this one. Or maybe that they are moving at the same velocity, but then acceleration is slowed down, right? Um, yeah, and then here they're slowing down. So this, we say it's speeding up, uh, speeding up, and then this speed is less than that, and here it's slowing down, right? So it's closely packed and then opens up, and then it's speeding up, right? And then it's closely packed and then it goes back to widening, so it's slowing down, right? And then you have these spaces in between here, right? So that's what I wanted to show you. Sometimes that when they are closely packed and they could be split and then closely packed, that actually means something. But we'll get back to that at a later stage when we start looking at the graphs, right? Because graphs will give us a relationship, right? Because there is a relationship between displacement, velocity, and acceleration. And then the relationship, you see, it goes like this, right? Right? And as we see here, there's also a relationship that goes from here back, but we'll look at that when we start looking at graphs, right? So that's motion on a plane, but we know that motion does not have to be on a plane. It does not have to move on a plane, right? It can be in the air, right? What about planes? What about when you throw a rock? What happens to it? What are forces acting on it? What is the motion there? How does the motion look like? Right. So let's just get to that, right? Let's say, for example, you have you're standing on a cliff, right? And down here there's water. There's water here, right? And then I can indicate it with that level, and yeah, standing at the top here. All right, let's say this is you, and then you have a ball on your hand, right? And then you what, you draw, you throw this ball up, and then it turns like this, and then it comes back to the water. So let's indicate your ball here. So it's the same ball, it's just, we're just indicating its motion, right? It's coming down, it's coming down, it's coming down, and then hit the water, right? So we can indicate this as our y1. Let's say this is the first position, initial position, y2, y3, y4, just like that, like that, like that, right? So we can also indicate the motion here. As you can see, it looks like a parabola when you look at it, right? So it means that somewhere we have a turning point, right? There's a point. Let me just remove this. Okay, so it means that there's a point, right, where the ball stops and then comes down, right? When we look at this motion, this type of motion, we call it free fall. This is free fall motion, right? What does free fall mean? There's no force acting on it. The only force acting on it is gravity, right? But we'll get to that when we look deeply and when we talk about free fall motion or vertical projectile motion, right? And what does it actually mean? But we have different types of motion. We had that one where a car moving in the plane, but we have the one in air, right? So this is free fall motion, right? And then we can also have a plane moving. Let's say this is our plane. No, plane is kind of difficult to draw. I can draw a plane, but that will take time. Okay, let's just try to maybe give it some effort, right? Um, so this is our, let's say this is our plane. It's a horrible plane, but yes, say this is our plane. Yes, it's moving in this direction, right? Say this is land, and then your plane went up, right? So this is also motion. It's not moving on a surface, but it's just moving on as uh in the air, right? Do the same laws apply? Do we still have displacement? Do we still have velocity? Do we still have acceleration? Yes, we do. We still have displacement, we still have acceleration, and we still have velocity. It's the same, right? It's just that now the displacement will be the acceleration will be different, right? You may have constant acceleration, zero acceleration, negative or positive acceleration, right? So it could be different type of things that could be happening, but it's still in motion. So these are different types of motion. Motion on a plane, motion in the air. Sometimes you'll have motions like this, where you have a cliff, right? Let's say this is your cliff. It's inclined at an angle. You are pushing up a wagon, a box, a car is moving up a cliff. It could be anything. But let's just be very simple and use a box, right? So let's say this is our box. It's been pulled to the right. It can be pulled by a carriage, a car, a person, anything, right? Or maybe it can be pushed from the side. The box is moving up here, right? The plane now is just inclined, but it's still the same plane, right? You do have what? You do have your displacement, you do have sorry, that's not displacement. Displacement is x, and then you do have a x, change in x, you do have a vx, your ax, and the change in time. You see all of these parameters, you can use them to define motion. So it actually defines motion, what is happening on the motion, right? So motion could be in all different types of way, right? Sometimes you could have something hanging from a ceiling, right? This could be a lamp, right? It could be a pendulum that you are pushing in this direction so that it moves to this side and then comes back here, right? So it could be a pendulum, still applies. You have change in displacement, you have change in velocity, acceleration, and change in time. So in a nutshell, that's what motion is like, right? So we went through the definition of motion, what motion actually is, right? So motion is a movement, actually, a movement that can be characterized in different planes, right? You can have a movement in a flat plane where you have a car moving, a person moving, and then we talked about what position is. So position is just it's kind of like a coordinate in a vertical in a Cartesian plane. I mean, it's where you are at a certain time. That's your position. But when you move from that position to another position, we're looking at displacement now, right? That's your change in position. That's displacement. And then when we look at the time that you took from position A to position B or x1 to x2, now we can start talking about the velocity. Like, okay, we saw you walk, right? We know your distance, we know your time, but can we find your speed, right? Can you find your speed, right? Speed and velocity are interchanged. You hear me change speed and velocity interchanged, but they're not the same. Speed and velocity have the same value, but velocity has something extra, which is a direction, right? So it's the same thing, but velocity just has a direction, right? So can you find your speed or your velocity? Okay, we can find it by dividing your change by what? By the time that we know it took you to get to position B. Acceleration. Okay, what about your acceleration? Right. Let's say, for example, we know you started from zero up to what? To a to a to a velocity, let's say, of about 5, right? The change in velocity is what? Is 5. Can you find your acceleration? Yes, divide by time, right? We get your acceleration, okay? And then we'll start we'll start looking at how can we actually use that to describe motion much better, and to actually um, understand what it means when something is in motion, right? Under mechanics. This is just what we went through, right? Just giving you a brief explanation on what each and every term means, how does free fall works, is it still motion, what actually applies, it's the same thing, all right? And then planes, that's a horrible plane, bear with me. And then you have motion on an inclined plane. You have motion which is swinging from which is suspended or swinging from a ceiling or somewhere. You can call them you can have as a pendulum, right? It could be your lamp on a ceiling lamp or a chandelier, something like that, right? So we'll just move to part 2. I'll just look at your equations of motions, and also like steps on how you can use those equations of motions to solve basic calculations or to solve some basic problems. Thank you.